Hello everyone, I'm teacher Masereka Joseph, and today I'm going to look at forces and its effects. I'm a teacher at Cass Secondary, and today we're going to look at turning effect of forces, and basically this is lower secondary content. Turning effects of turning effects in opening a door, in opening a spanner, and it leads us to what we call moment over force, whereby moment over force is the product of force and its perpendicular distance from the line of action. Or the line of action, you can call it the pivot, you can call it the fulcrum. And the unit of a force is Newton meter, because it's a multiplication between force and distance. The only big difference between a moment of a force and work done is that a moment of a force basically looks at the perpendicular distance. The distance has to be perpendicular to the force. And that equation that relates moment of a force, which is denoted by tau in physics, is given by force and then times the perpendicular distance. Let's look at a simulation about moments. Let's look at a simulation about moments, how perpendicular effects, how perpendicular distance affects the moment that is got at last. And this simulation basically is going to look at, is basically going to help us understand more how the distance affects the force. Now this is a scenario that I have, and I'm going to try to show us how distance affects the balancing of the forces, how it affects the balancing of the forces. Now let me use 5 kg. Let me use 5 kg at this very distance, and let me pick 5 kg again and put it at this very at equal distance. Then I need to remove that. So we observe that at that very point, because they are at equal distance, let me put my ruler. Because they are at equal distance, we can see that left hand side is at 1.5 and right hand side is at 1.5. So at that very point, they are balancing because they are at the same distance from the line of action. How about if we extend this to a distance of 2 meters? Wow, we pretty observe that we put it at a distance of 2 meters. Now the right hand side is now at a higher distance, therefore its moment is pretty higher than the distance at the left hand side. How about if we would put this also at 2 meters? Let's observe what happens. Wow, we pretty observe that when you put it at 2 meters, it also balances. How about if we put this at the left hand side at 0.5? What could happen? You observe that when you reduce the distance, it also reduces the force. It also reduces the moment. How about if we could also reduce maybe this to, let's put it at 1.25? You observe that it's still at a higher distance from the fulcrum, or what you call the pivot. So that basically shows us that moment of a force increases with increase in distance. So when you increase the distance, you also increase the moment of that very force. When you increase the distance, you also increase the moment of that very force. Let me go back to my slides. So that is what we have there from the simulation, that when you increase the distance, you also increase the moment of that very force. Now, let me look at example of moment of a force here, and you can see that I have my force here, I have a force here, and then I have a perpendicular distance. For it to be perpendicular, it should be making angle 90. It should be making angle 90 with the perpendicular distance. Now, due to the training that I've obtained, I have been able to embed this let me also open for us a YouTube example to also give us more examples of moment or forces, and also maybe observe what I've done in the simulation and see what is there. It's pretty opening. Let's wait for the YouTube bit of it, also to give us more highlight about moment of a force, moment of a force. It's pretty lot. All right, now it has opened. I really appreciate physics for education, and we're going to see an example here also on YouTube how this channel they also did it, and I really recommend you to also tap in it. And now when you observe that, that is a Fuse School Global. It also did this very example.
Think of a spanner loosening a fixed nut, or a child on a seesaw, or a door opening around a fixed hinge. All of these things are connected by something called moments. A moment is the turning force around a fixed pivot. The pivot is the nut, or the middle of the seesaw, or the hinge. We can have one moment acting, which results in a turning force. Or if something is balanced or in equilibrium, the moments are equal and opposite.
We observe that what he is showing that Fuse School Global, that is in Fuse School Global, that we can have two bodies that can be balancing, just like I've shown us in the simulation.
To be balanced, this lighter child needs to sit further away from the pivot, and the heavier child needs to be closer.
So that still shows us how distance affects the moment.
This is because the size of a moment is determined by the force and a distance. So the moment of the lighter person is 500 newtons multiplied by 2 meters, 1000 newton meters. And the heavier person is 1000 times 1 meter to also give 1000 newton meters. They're perfectly balanced on their seesaw. Did you notice that moments are measured in newton meters, Nm, because force is measured in newtons, N, and distance in meters? Note that the distance must be the perpendicular distance from the pivot to force. Here's another example. Can you work out what moments the woman is applying to tighten the wheel nut? Pause the video and work it out. Did you get 3 newton meters? Were you careful?
So in this video, they are still showing us that we can observe still moments in turning a car wheel, and the distance basically it should be perpendicular. We are interested in it should be a perpendicular distance. So in other words, in everything that we're going to do for us to get moment of a force, it should be the force and the perpendicular distance. So that it being perpendicular, it should make an angle 90, just like when this very moment will be advanced now to a level now where you'll be applying it in ladders or ladder system. You need to keep in mind that you need that distance should be perpendicular distance. That is one of the examples and one of the applications as seen from the YouTube channel for Fuse Schools. Now there is a simple example here that telling us that given a force of 3 meter and a perpendicular distance of 4 meters. Now the moment they call it perpendicular distance means that they have already given us the distance. Now they want us to find the moment. I'm gonna use my light pen here. In other words, moment which is given by tau is given by force and distance, but this distance should be a perpendicular what distance. So in other words, our force is 3 times the distance, which is 4, this being newton times a meter. So when you multiply this, it is going to give us 12 newton meter, which is a moment of a force. This is moment moment of a force, moment of a force. So basically that's how we determine moment of a force, by basically multiplying force and distance. Now, it being a force, it means that the force was already given as 3 meters, and they've already called it perpendicular. Perpendicular means that this is what we have. Uh, they are making angle 90. So let's say that maybe perhaps this is the force, and if this is the line of action, this is the line of action, this should be angle 90, and then the distance is 4 meters. So this is the line of action. Let's call it maybe the pivot. So moment of a force should be the force, and the perpendicular distance. Perpendicular meaning that they make angle 90 between each other, and that's basically how we find moment of a force. Now, real life application of moments of forces. We looked at opening a door. We can also have screwdrivers. We have seen at least average, have traveled by cars, and basically engineers, they use screwdrivers. We can have a beam balance. A beam balance can be for weighing objects, for weighing materials, for weighing everything. Maybe you are working in an industry, you may need a weighing balance. We have a simple activity about how we can also check ourselves whether we have understood some that. And we have the question that says list more application of moments of forces in real life. And I have a quiz, a simple quiz. I have my link there, which is embedded in this very slide. Now, the moment you click that, it takes you directly to the Ministry of Education portal, that you can be able to observe the quick quiz that I have said uh, to check the simple understanding of moment of forces. Now, the moment you reach on this very quiz, you log in. Now, that is Masereka Joseph. Then when you log in, it will directly take you to the quiz. Should directly take you to the quiz. Now, when I reach here, then I find an assignment about moment of a force, assignment 1, and then it is there. You can, there is a quiz, but me, I can preview the quiz. The quiz, it's me who had to set it. But for a learner, you'll just reach there and then you open the quiz. Allow me not to preview the quiz, because then I'll have opened it. So the moment you open that link, it will directly take you to the quiz. You log in, then you attempt the quiz. Then I'll be able to see the attempt that has been done to the quiz. That is a Ministry of Education portal. When you tap that, it will take you directly. And in the conclusion, I want to say that moment of a force is basically the product of force and the perpendicular distance. Please take note that the distance should be perpendicular. The moment is not perpendicular, it means that that is work done. But if the distance is perpendicular, it means that that is what? That is a moment. I want to acknowledge Fate.Quadrado. It is for simulation. It is what I was using for simulation, Fate.Quadrado. Then I also want to acknowledge Fuse School Global Education, because of the YouTube video, and then the Ministry of Education of Uganda. On that note, therefore, allow me to say thank you for watching, and if you find this video interesting, I'm going to be uploading more videos basically for physics and mathematics. In the next lesson, I'll upload a video about AC circuits, that is for A-level students, and I'll also be able to upload some videos. Thank you for listening.